Okay, so continuing our topic in finding the roots of nonlinear equation, meron tayong another method which is the regular falsi method. So in our previous topic, we have discussed the bisection method. We also discussed the second method. This time, we will be discussing about regular falsi method in finding the root of a nonlinear equation. So regular falsi method is actually a combination of second method and bisection method. So if you will be noticing here, yung sa procedure, yung first part is actually a second method. And then yung sa step 3 and 4 is nakuha natin siya sa bisection method. Okay. So, to solve for the root of nonlinear equation using regular falsi, first is we have to find 2 points, yung PO and P1. So, which is yung point 1 dapat natin is less than P1 and the product of its function is less than 0. So, if maalala nyo pa, this is actually in the method for finding the roots of nonlinear equation using second method. Ito din yung first step natin. Okay? So, pangalawa, if nakuha na natin yung two initial points, we have to take the interval, yung value ng Pn, para malaman natin yung value ng next iteration natin. Okay. So, if maalala nyo din, ito yung step 2 natin for in second method. So, you have to take the interval of your two initial points. So, para makuha itong Pn natin, yung interval natin, we just have to use this equation. Okay? So, we have 0.1 minus the function of P1 multiplied by the P1 minus PO over the function of P1 minus function of PO. This is actually yung equation din natin sa pagkuha ng interval doon sa ating second method. Okay? So, in step 3, yung step 3 natin, if FPN is 0, then yung PN natin is our exact root. If FPN is less than 0, or the function of Pn multiplied by the function of P1 is less than 0, that is a negative value. Dapat ito, negative value din ito. Then, yung Pn natin sa susunod is the new PO. So, yung Pn natin sa susunod is yun yung magiging new PO natin. Otherwise, yung Pn natin is our new P1 in the next iteration. So, pag mapapansin nyo, itong step 3 is actually yung method din natin, yung procedure din natin sa pag-solve ng root of nonlinear equation using bisection method. Okay? So, if Pn, yung function ng Pn natin is less than 0, that is a negative value. So, let the Pn be the next PO doon sa ating next iteration. If not, our Pn be the new P1. Okay? Yun yung pinag-iiba doon sa second method kasi ito kinuha natin sa bisection method. Diba? Pag naalala nyo dun sa second method, yung if our function of Pn is equal to 0, then that is also our exact root. Diba? If not, yung PO natin sa next iteration is the value of our P1 nung last, and then yung value ng P1 natin is our value for Pn nung last. Yun yung second method. Diba? So, this is actually from bisection method kasi ito din yung method natin to find our value of P1 and PO doon sa ating next iteration. Okay? Then, our last step is we have to repeat our step 2 and step 3 until the function of Pn is equal to 0 or approximately 0. Doon pa lang tayo mag-stop ng iteration. Okay? So, to understand further our method, yung Regula Falsi. So, this is actually iteration din. Katulad ng bisection method, katulad ng second method, ito, iteration din. So, you have to iterate yung ating equation until yung function ng Pn natin is equal to 0 or approximately equal to 0. So, tsaka pa lang kayo mag-stop and then yung value na na-solve natin for Pn is now the value of our root. Okay? So, let's take an example. So, we have here an example. We have to find the So we have to find the positive root of the function fx is equal to x raised to 4 minus 7 using the regular Falsi method. So if you notice, yung example natin, ito din yung first example natin sa bisection method. Ito din yung first example natin sa second method so that you can compare yung mga sagot natin. So yung mga sagot natin is actually near doon sa isa't isa. Either you're using bisection, second, or regular Farsi. Yung lalabas na root of our nonlinear equation is actually or approximately equal. Malapit lang sila sa isa't isa. Okay? So, yung first step natin is we have to find our 2 starting interval, 2 points the first starting interval natin. Since our function is continuous, we have to find our first starting interval. So we say we have x. Okay? So, the same process doon sa ating bisection second method, if maalala nyo pa. So, say we have to start at 0 with an interval of 1. Okay? So, mag-interval tayo pa rin ng 1. So, 0, 1, and 2. So, substituting this value in our equation, makukuha natin yung function. So, function of 0 is negative 7, function of 1 is negative 6, and function of 2 is 9. So, pag tinitignan natin ito, ang kukunin nating point 1 and point 2 is yung 1 and 2. Bakit kamo? Yung PO natin is less than P1. That is correct. And then yung function of our PO multiplied yung function ng ating P1 is less than 0. That is also correct because this is negative 6, that is 9. So if you multiply a negative and a positive, magiging ang value natin is less than 0. Okay? And that would be now our 2 points. Yung PO natin is 1 and then yung P1 natin is 2. Okay? So, meron na din tayong ng function ng PO which is negative 6 and yung function ng P1 which P2 which is 9. Okay? So, next step is we have to solve for the value of our interval, yung Pn natin. So, yung Pn is equal to P1 minus the function of P1 multiplied by P1 minus PO over the function of P1 minus the function of PO. Okay? So, we have values, yung mga function natin, and yung P1 and PO natin. We can directly calculate our Pn, which is equal to P1, that is 2, minus. This is actually the same with the second method. Pag maalala nyo pa yung topic natin last meeting. Yung function ng P1 natin is 9 multiplied by 2 minus 1 over the function of P1 that is 9 minus negative 6. So yung Pn natin, yung value ng Pn natin dito is 1.4. So if you try to look at your notes here, the same lang yung makukuha natin sa second method, yung notes ninyo sa second method. So yan na yung magiging value ng Pn natin. So ano ngayon yung function ng Pn natin? So just have to substitute 1.4 raised to 4 minus 7. That is equal to negative 3.1584. So, dito na tayo magde-decide kung ano yung next value ng PO and P1 natin sa ating next iteration. Okay? So, this is the first iteration. So, ang sabi natin dito sa bisection method, if our function of Pn is equal to 0, then Pn is the exact root. And since hindi naman approximately 0 or 0 yung function of Pn natin, meron tayong condition dito that if Fpn is less than 0 or Fpn multiplied by Fp1 is less than 0, that is a negative value, then Pn as the new PO, otherwise Pn is the new P1. Okay? So looking at this, we have a negative value. Negative value. So yung next iteration natin, which is yung n is equal to 2. Ano na ngayon yung magiging PO natin? Anong na ngayon yung magiging P1 natin? So sabi natin, if the function is negative, let the Pn be the new PO. So since yung value natin dito is negative, our Pn is our new PO in the next iteration. So yung PO natin sa next iteration natin is equal to 1.4. Yan yung ating Pn. And then yung P1 natin is still the same, which is 2. Okay? So ganyan. Ito na ngayon yung magiging PO and P1 natin sa next iteration. So, we need to solve again for the value of Pn. Then, kunin natin yung function ng Pn. And, doon sa function of Pn, ma-determine natin kung itutuloy pa rin natin yung iteration natin. So, pag ang nakuha natin dito is positive. So, pag nakuha natin dito sa function of Pn, so say, nakuha natin is a positive value. Pag nakuha natin is a positive value, yung PO natin and P1, ang PO natin is still the same pag sa next iteration. And then yung P1 natin is our Pn. Pag positive yung nakuha natin dito. Okay? So, since negative yung nakuha natin, yung PO natin is yung Pn and yung P1 is still the same. Okay? So, isosolve ulit natin yung value ng Pn sa next iteration. So, if we have N2, yung PO natin is 1.4. Yung P1 natin is 2.0. And actually, nakuha na natin yung function ng mga ito, di ba? Which is equal to yung function ng PO. Ito yun, negative. Ito pala, kasi PO natin is negative 3 point. Ito yung function ng PO natin and yung function ng P1 natin is this. So, yung function ng PO natin is negative 3.1584 and the function of our P1 is 9. So, isosolve ulit natin yung value natin ng Pn. So, using our equation which is this, masosolve natin yung new Pn natin. substituting yung values natin, ang new PN natin is equal to 1.5559. Okay? So actually, this is the same doon sa sample problem natin sa second method. Ang pinagkaibahan lang dito sa regular falsi doon sa second method is yung kung ano yung magiging value natin for the next iteration. Diba? Kasi yung sa second method, tinitignan pa rin natin yung function actually ng Pn. Pero dito, tinitignan natin kung negative or positive. So, madidetermine natin kung ano yung next PO and P1 natin. And then, dun sa second method, madidetermine natin kung ano yung value ng ating PO and P1 gamit din yung ating function ng Pn. Diba? So, pag if you still remember yung sa second method natin, yung PO is equal to the P1 of last iteration, and then yung P1 is equal to the Pn of the last iteration. So, eto, magre-rely tayo pag yung function ng Pn is positive or negative. Okay? So, eto, yung first two steps, sabi ko nga, second method. Yung next two step is actually bisection method. So, kaya combination of second and bisection yung ating regular falsi. So, yung function of Pn natin is equal to ang function of Pn natin is negative. Yan. So, yan yung magiging function natin. So, negative pa rin ito. So, yung next iteration natin, which is n is equal to 3, o yung PO natin, yung new PO natin is the Pn doon sa 2. And then, yung P1 natin is still yung P1 natin sa 2. Okay? So, ganyan pa rin tayo. And then, kukunin na naman ng Pn, and then you solve for the function of Pn hanggang mag-0 itong value natin dito. Hanggang sa Fpn natin is equal to 0. So, i-iterate natin siya. So, calculate. Ito na yung magiging summary niya. Pag kinalculate natin siya, paulit-ulit, ito na yung magiging value natin. So, actually, in here, we can stop it here already. Diba? Ito. Kasi this is approximately 0. We can stop actually here at n is equal to 8. Kasi ito approximately 0 na. Pero tinuloy ko pa rin siya para mas accurate. Kasi pag titignan nyo din yung values dito and yung values dito is almost or exactly the same. 0.001 lang yung kaibahan. So dito, pag nakakuha na kayo ng ito approximately, you can stop it here, yung sa 8. Okay? So, you can stop it there na. Okay. So, ito yung resolve natin sa number 2. So, yung lumabas dito sa FPN natin is negative. So, yung PO natin dito is yung value ng PN natin, which is actually this. And then, so, ikopyan nyo rin lang yung function niya. And then, yung P1 pa rin natin is 2. Okay? So, kunwari, ang lumabas dito is positive. Yung magiging P1 natin dito is yun yung PN natin. Okay? Pag positive ang lumabas, yung P1 yung papalitan natin na value ng PN nung last. And then, the same yung PO. Okay? Pag positive yung lumabas dito sa function. So, since negative, ang papalitan nating value is yung PO. Papalitan natin siya ng value ng Pn nung last iteration. Okay? So, dito sa ating third iteration, yung function of Pn natin is negative 0.3508. Negative pa rin siya. So, yung PO natin is yung value natin ng Pn. So, eto, pag titignan natin ito, yung value natin dito is actually the value of our Pn here. So, the same pa rin yung P1 natin dito. Okay? So, pag kinuha natin yung function, negative pa rin. So, pag negative pa rin, yung Pn natin dito is magiging PO natin sa next iteration. And the same pa rin yung P1. And so forth and so on. And so, calculating now our equation, the root of the equation is approximately equal to 16265. So, ito hanggang dito tayo. So, ito na yung magiging root natin. Okay? Or this one. 6266. Mas accurate ito. 6266. Okay? So, that will be now our answer in our problem 1. And if you compare this, yung root natin nakuha natin using regular falsi doon sa root natin doon sa nakuha natin sa second method and bisection method, they are almost the same actually. Malapit lang sila sa isa't isa. Okay? So, let's move on to our second problem. So, we have to find the approximate positive root of the given equation using regular Farsi. So, assumption ko pa rin is I will start at 0 at an interval of 1. So, interval ko pa rin is 1. So, 0, 1, 2. Okay? So, yung function natin dito, just substitute itong value natin dito sa equation. Makukuha natin negative 1, and 61. So, in here, madidetermine na natin kung anong PO natin, which is 1, and P1 natin, which is 2. Since yung PO natin is less than P1, and yung function of PO natin multiplied our function of P1 is less than 0. Okay. So, pag may P1 and P2 na tayo, in our first iteration, we can now solve for the value of Pn. Diba? That is P1 minus the function of P1 minus PO. Okay? So, importante itong equation because gagamitin natin itong equation to solve for the value of Pn sa second method and sa regular falsi method. Since sa bisection method, divide lang natin ng 2 itong P1 and P2. Pagkuha ng Pn doon sa bisection, di ba? If maalala nyo pa. Okay? So, solving our Pn for the first iteration, ang magiging value natin dito is equal to 1.0161. Okay? And then the function of our Pn, that is equal to 1.0161 raised to 6 minus 1.0161 minus 1. Ang value natin for the function of Pn is equal to negative 0.91537. Okay? So, our function of Pn is a negative value. So, yung next iteration natin, so yung function of Pn natin, if our n is equal to 1, yung function of Pn natin is a negative value. Negative. So, pag susunod na iteration natin, yung PO natin is equal to Pn1 and yung P12 natin is equal to P11. Parehas lang sila. Okay? So, our value here sa PO2 that is equal to 1.0161 and yung value natin dito is 2 pa rin siya. Okay, ganyan. And then solving for the Pn of these two, ang value natin is equal to 1.0307. So you just have to substitute yung values dito doon sa ating equation ng Pn. So, ito yung equation ng Pn to solve for the Pn. So, ito lang. Okay, so to solve for this Pn. And then, you have to solve for the function of Pn. So, yung function of Pn natin dito is actually negative 0.83192. Okay? So, negative pa rin yung value natin dito. So, pag nagpunta tayo sa next iteration, which is n is equal to 3, yung PO3 natin is equal to PN2, and yung P13 natin is equal to P12. doon sa second. Ito yung subscript natin dito is our number of iteration. Yung iteration natin. Okay? So, ganyan lang siya. So, pag ito, uulitin ko na naman, pag yung function natin of Pn is positive. So, yung magiging P 01 up to natin is equal to P01 and then yung P12 natin is equal to Pn nung 1. So, ganyan. Baliktad naman ito. Baliktad dyan. Pag positive yung function of Pn natin. And then, you iterate that, you have to iterate again and again until we have the function of Pn is equal to 0 or approximately 0. Okay? So, I have here the summary of iteration kasi masyado siyang mahaba actually ito. Meron akong summary dito ng iteration. Okay? So, this is actually negative 0.3368. So, para mas accurate, you have to continue iterating this value para mas accurate tayo. So, sa problem ko, I just stop at 25. So, that is negative 0.3. So, this is approximately 0. Pero sabi ko nga sa activity, sa exam, and sa quiz, ang approximate natin dapat is 3 and any number, 3 zeros. Okay? So, you have to continue iterating this, 25. I-iterate nyo pa. Pero actually, yung value natin malapit din lang dito, 1.314 something. Kasi this is actually approximately to 0. Diba? Pag kinuha natin is 2 decimal lang. Okay. So, ito yung first iteration natin. We have this. Okay. So, negative yung value natin. Kaya yung Pn natin dito is equal to the PO natin dito. And this is actually the same. Okay? So, dito negative din. Kaya yung value ng Pn natin is our value for our PO here. And then, ito, parehas pa rin siya. And so forth and so on. So, kindly check my calculation here if these are, if my value, if my calculated value is correct. So, kindly check itong values natin dito using your own calculator. So, yung problem number 2 natin, our root is equal to 1.1314. So, ito na yung magiging root of our non-linear equation. This is approximately 1.1314. Okay? So, that's it for the example of the regular falsi method.